Paris, 1832. A young man sits at a small desk in the dark, writing as if the paper itself were running out of time. He is 20 years old. By morning, he may be walking toward his death. In the France of his time, mathematics belonged to academies, examinations, authority, and patience. But Galois' mind moved like lightning, too fast, too short, too unwilling to explain itself. What he handed in was dismissed as confused, careless, incomprehensible. But perhaps the real problem was this: he had already arrived where no one else was ready to go. For centuries, mathematicians had asked the same question: can an equation be solved by a formula? Galois turned the question upside down. Do not stare only at the answers. Look at the relationships between them, at how they exchange places, at the hidden order that remains. Later, people would give that order a name: group. But his world was not only on paper. In the Paris of the 1830s, the fire of revolution had not burned out. Young men talked of republics, liberty, betrayal, and sacrifice. Galois stepped into that fire too. He studied symmetry, yet he was torn apart by the asymmetry of his time. He was no quiet saint in a study. He was fierce, proud, easily offended, and again he pushed himself toward danger. This is what makes his story sting. He was not a perfect genius from myth, but a real 20-year-old. He wanted to understand equations, and he wanted to change the world. Prison slowed time down. For Galois, that slowness was perhaps a cruelty worse than any other punishment. He had too much to write, too many structures to catch, and his life kept being interrupted. Examinations, politics, arrest, illness, poverty, and death drawing ever closer. The world never gave him enough time. In May of 1832, a duel was arranged. The exact reasons remain tangled in rumor, politics, and personal conflict. What matters is the pressure it created. Galois seems to have understood that the next morning might be the end. So he turned to the only thing he could still control. He wrote. This was no ordinary final letter. It contained no long self-pity, only a kind of brutal clarity. He told his friend Auguste Chevalier that these manuscripts were important, that they should be shown to people who might understand. He was like a man on a sinking ship, throwing the most precious things he had toward the shore. If only someone would catch them, the future would change. In the margins of this night, one can feel that famous cry attributed to his manuscripts. I have no time. Imagine that the solutions to an equation are a set of hidden points. You may not know where each point is, yet you can study how they exchange places with one another. Some exchanges break the structure. Others do not. What Galois saw was precisely these invariant relationships. He turned the problem of solving equations into the problem of studying symmetry. A group is not a cluster of numbers. It is more like a set of rules for actions. Rotate, swap, reflect, combine. Do one action, then another, and the structure remains traceable. This language would later become the core of modern algebra, and it would enter physics, crystallography, coding, and cryptography. Before Galois, mathematicians often searched for formulas the way people search for keys. Was there a universal formula that could open every fifth-degree equation? Galois did not merely tell you that some doors cannot be opened. He told you why. Mathematics shifted from searching for answers to understanding structure. When he finished, he was still just a 20-year-old young man. On the paper, the future. Outside the window, morning. On May 30th, 1832, Évariste Galois walked to the Duel. The field was quiet. The air was pale. History has left shadows around the details of that encounter. But the result is clear. Galois was shot. The next day, May 31st, he died. He was 20 years old. A life so short the world barely had time to know him. But his ideas had already left the room. For a long time, the world still did not know what it had lost. His manuscripts had to wait. Other minds had to return to them, unfold them, repair the gaps, and recognize the shape of the theory inside. But eventually, the future answered. Galois' name became attached to one of the great turning points in mathematics. The same way of thinking about symmetry now reaches far beyond the original problem. It appears in geometry, number theory, physics, crystallography, coding, and cryptography. The young man who could not make his own century understand him helped teach later centuries how to understand structure itself. He did not live long enough to be understood, but he changed what understanding could mean.